Assalamualaikum and a very good afternoon. Okay, today we cover our last chapter which is chapter 7, solubility behaviors of polymers. So we will cover about the solubility parameter, solution thermodynamics, and networks and swelling. Okay, solvent in polymer. It is always used in the following process. First, in carrying out the polymerization reaction and study of the kinetic process. Secondly, in some polymer fabrication, such as casting of thin polymer films, so it needs some solvent to dissolve it. And third one, in the formulation of adhesive surface coating, such as paints and printing ink, of course it needs some solvent. And in the characterization of polymer structures, such as NMR, FAR, and so on, and the determination of molecular weight and the molecular weight distribution. Of course, in GPC, it needs some solvent as a mobile phase. Alright, so first, how does the polymer dissolve? Okay, once a polymer placed in a solvent, so polymer will dissolve in several steps. First is solvent must wet the polymer. Okay, so the solvent will diffuses into the polymer if high molecular weight polymer. So it will swell. Okay, for high molecular weight polymer, it will take longer time for the solvent to diffuses. So it depends on the sample size, temperature, and so on. So if polymer is cross-linked, polymer only swell. So a solvent, usually thought of as a liquid, is a substance that is capable of dissolving other substances and forming a uniform mixture called a solution. So the substance dissolved is called the solute. Means that substance together with the polymer and the solvent, okay, the substance with the solvent we call it as a solute, and is usually considered to be the component present in the smallest amount. When a polymer dissolves, the first step is a slow process called as a solvation, and then after the solvation, linear and branch polymer dissolve, but network and cross-link polymer remains in a swollen condition. It's only swell. Okay, dissolving a substance or liquid in another simply means uniformly distributing the molecule making up each of the two parts. Okay, solute plus with the solvent, it will become a solution. So the receiving liquid is the solvent and the substance which is dissolved is the solute. And the resulting mixture is the solution, and the learned name of the process is called as a solvation. So this is the some terms that we have to know. Okay, two ways to determine the solubility parameter. Sigma, okay, for polymers. Sigma ke ni? Tak ingat kan sigma. Sigma itulah. So it involves the swelling of a lightly cross-linked polymer in a series of solvent. Assume polymer have same sigma, which is solubility parameter, as the solvent that yield to maximum swelling. And the problem of this method, it will affect the accuracy and inconvenience, which is uneasy to prepare the light cross-link network and compilation in crystallinity. Okay, solubility parameter that would provide a systematic description of the miscibility behavior of the solvent is given in this table, which is by using the Hildebrand solubility parameter. So Hildebrand solubility parameter is for non-polar material. And the second one is based on the calculation based on group contribution. So molecule can be broken down into set of functional group By using molar attraction constant, contribution of group can be calculated. So by including a branch hydrocarbon molecule containing other functional group, a table of constant can be obtained and used to calculate solubility parameter. Okay, the branch solubility parameter provide a numerical estimate of the degree of interaction between materials and can be a good indication of solubility, particularly for non-polar materials such as many polymer. So material with similar value of solubility parameter are likely to be miscible. So what is miscible? Means that two components can mix or homogenize together. For non-polar solvent, solubility parameter is equal to square root of the difference between enthalpy of evaporation. Okay, and the product of the ideal gas constant R and the Kelvin temperature divided by molar volume. So this C is the cohesive energy. So since it is difficult to measure the molar volume, it is equivalent as molecular weight. So m divided by density and substitute in the V. Okay, first you have to know this equation. You have to know what is the term for sum of the G, sum V, sum G, and so on. So sum G means that total molar attraction constant. So this value we can refer G value in the this table, okay, when equivalent table. So it has the value for each group. Okay, P is the density also be given, and M is the molecular mass of repeating units. And you have to find the molar mass, okay, molecular mass or molar mass you have to find based on the atom number. And the unit measurement is joule, half cm, -3/2. And G, molar attraction constant G, can be used as estimation of solubility parameter of polymer. So kena ingatlah dia punya equation ni. Okay. So nanti bila dah mula-mula cari dia punya molar mass, and then bila dapat molar mass, kita refer value in one prevalent table ni. So cari molar mass by using this periodic table, and then use this equation by substituting the G volume. Okay, the G volume, the G constant value. And then we will get the solubility parameter value. Alright, so let us apply the scheme on H2O, which has a molecular weight of 18 gram and density of 1 gram. So first, look at this equation. Okay, dia guna equation ni satu. Yang ni dia punya molar mass dia. Okay, molar mass dia sama dengan 18. Okay. 18 gram per mole. So by referring the value in Van covalent table, we have H is 140, H 140 plus with the OH, okay, H dah ada, OH nilai dia 754, okay, so tambah, kita dapat 894, dapatlah 894, and then 894 masukkan dalam equation yang ini, 894 times with 1 divided by 18. Okay, bahagi dengan 18. So dapatlah dia punya value dia 49.6. And this value is not far from that determined from equation 4, which is 47.5. Okay. So example, polyvinyl acetate and polyvinyl alcohol have density of 1.19 and 1.29 respectively. Calculate their solubility parameter and comment about their relative solubility in water. So, boleh buat ni sebagai exercise. Okay, ingat cara dia mula-mula awak kena cari dia punya molar mass and then awak cari dia punya solubility parameter by using formula. Okay, total G times density over M. Okay. So solubility parameter, the smaller the difference between solubility parameter 1 and solubility parameter 2, making it more favorable for the polymer to dissolve in the solvent. In general, if there is no solvent-polymer interaction, we can safely predict the solubility of sigma 1 minus sigma 2 is less than 1 for non-polar polymer. In cases where there is some weak solvent-polymer interaction, such as due to dipole moment and weak polar group, solubility might be possible with sigma 1 minus sigma 2 is less than 4. For those with very strong solvent-solvent polymer interaction, which is hydrogen bonding, solubility could still be possible with approximately 15. So solubility parameters are often used in industry to predict compatibility of the polymer used in the chemical resistance test, swelling of cure elastomer by solvent, formation rates of solvent, characterization the surface of pigment, fibers, and filler. Moreover, the usefulness of polymer in many technological applications is critical dependent on the solubility parameter. Okay, solution thermodynamic. Okay, solution thermodynamic is the process of dissolving polymer in a solvent. Is also guided by the basic thermodynamic laws. So it will occur spontaneously if the Gibbs free energy is negative. Okay, this is the equation for solution thermodynamic. G this equal to H minus T S. Okay, the change of S. T is the temperature. Okay, S this is the entropy of the mixing. And H this is the enthalpy of mixing. And this is the change in the Gibbs free energy or mixing. So in dissolving the polymer in a solvent, the movement of molecules are being increased, which is the kinetic energy increases, hence the enthalpy of dissolution is positive. So in order that the change in Gibbs free energy or mixing must be less than 0, we must have the temperature of entropy of mixing is bigger than the enthalpy, the change of the enthalpy of mixing. So solubility occurs when the Gibbs free energy of mixing is equal to negative. So negative value of the change in Gibbs energy indicate that the solution process occurs simultaneously. So the controlling factor is T, temperature. Higher T will increase the value of temperature and the change of temperature and entropy of mixing. Hence, the more negative will be the change in Gibbs free energy, so the more soluble the polymer will be in the solvent. And the T delta change S ataupun temperature of the entropy of mixing is always positive because there is an increasing in entropy on mixing. So signs of the delta G depend on the magnitude of delta H. And heat of mixing is always positive. Okay, molecular attraction. Liquid and solid differ from gas. Okay. Uh, for a solution to occur, the solving